Now we are.
Yeah. Okay, today we're going to learn about arithmetic sequences. Arithmetic looks like arithmetic. It's just all in how you say it. So let's talk about an arithmetic sequence for a moment. If I say I have -3, whoops, that's a positive one. -3, 1, 5, 9. Can we look at this set of numbers that I'm calling a sequence and find a pattern between the numbers? -3 to 1, yes, Maximus?
4.
So if you think about a number line, if I'm at -3, how do I get to 1? 1, 2, 3, 4 spaces. So if I can add 4, well, how do you go from 1 to 5? Add 4. How do you go from 5 to 9? Add 4. So since this same going from one term of my sequence to the subsequent term, we add 4 each time, and every time we're adding the same thing, this makes this an arithmetic sequence. Do you see where it looks like arithmetic? Arithmetic?
Yes.
But it's arithmetic. I don't care how you say it. It's not going to make a difference. But this adding 4 each time, if I were to say, what is the 5th term of that sequence, what would you say?
4.
So if this is the first term, this is the second term,
Be 13.
Say
give me the 5th term.
13.
And you're saying it's 13. How did you get that?
We
I
added
plus
4.
4.
Good. You added 4 to the previous term to get the subsequent term. What would be the 6th term?
7. Wait, yeah, 17.
17.
Yeah.
Okay, good. That's a comma. Because we're adding 4 to both. We're adding 4 to the previous term to get the next term. In order for it to be arithmetic, it must have the same increments, just like how we determine if something's linear or not linear. If we look at our terms, like how, if we compare the slope, if we look at how the y's are changing, the y values, if they change by the same amount, we call it linear. But if 3 of the 4 numbers change by the same amount, but from the 3rd to the 4th, it's different, is it linear? No. Same thing here. If, for instance, if this were 10, this would no longer be arithmetic because it doesn't have the same difference from one term to the next. So I'm going to introduce something to you called a common difference. Okay? Common difference. AKA also known as D. We're going to refer to the common difference as the letter D. The sequence that I just erased off the board, its common difference was 4. Let's look at this next one. Let's do an easier one. Let's do 15, 13, 11, 9. Is that an arithmetic sequence? What should you look at first, Sophie?
How much they're increasing by over time.
Yeah, how do you go from 15 to 13? You subtract 2. How do you go from 13 to 11?
Subtract 2.
Subtract 2. How do you go from 11 to 9?
Subtract 2.
Subtract 2. So this is the first term, second term, third term, fourth term. What would the 5th term be?
7.
So if I subtract the 2, 9 minus 2 gives me 7. What about the 6th term?
5.
Okay, good. This is an arithmetic sequence with a common difference of -2. D is equal to -2. Any questions? Yes, sir.
Get in the paper.
Can you what?
Get in the paper.
The assignment paper? Sure.
So if you put 2, would you get it wrong? Like
Yes.
you put D equals 2.
Because you got to know that we're subtracting 2. That's a very good question. So adding 2 and subtracting 2 are very different. So yes, This is related to remember our slope-intercept form where y equals mx plus b? This common difference is the same thing as the slope, which we're going to learn here right now. I have an explicit formula that I want to give you. I'm going to get rid of this. The explicit formula is, and I'll explain it. This is the explicit formula. When you get your paper, I want you to write this at the top of it. This A, you read this, A sub 1. All that means, it's the first term of the sequence. A sub 1 is the first term of the sequence. Referencing this last one I just did, what's the first term of the sequence?
15.
15. Okay. Let me use a different color. I'll explain this in a second. What's the D in this sequence? What's the common difference?
-2.
-2. This is how you write an explicit formula for any arithmetic sequence. Now, I don't want you to leave it like this because we can math it. We can do some math. We can do the distributing here. So we've got 15 plus -2n plus 2. Combine my like terms. I'm running out of space. -2n plus 17. The explicit formula and its most accurate answer for this sequence of 15, 13, 11, 9, ... This right here, the number in front of n, just like the number in front of x, is our common difference. Just like any number here would be our slope, common difference and slope are synonymous. They're the same. Let me talk about this, n and that n. We read this as A sub n. What does that mean, Miss B? That makes no sense to me. I know you're speaking English, but I got no idea what that means. A sub n just means that we can find in an arithmetic sequence any number in the line of a whole bunch of numbers in a sequence. We can find what that number is. So if I were to say, just like I asked you, what is the 6th term of the sequence?
Miss B, can I have my paper so I can write this down?
Yes. First term, second term, third term, fourth term, fifth term, sixth term. You told me what that sixth term was in because we were figuring it out. But what if I asked you for the 106th term? The nth term can be, and this is a lot to take, but I'll explain it a little more. The nth term can be found by taking, let's say I want to know the 106th term. Do you want to subtract 2 from 15 105 times? I don't. Remember, mathematicians are lazy. We try to do things a lazy way. So I want to find the 106th term. The nth term I can get by taking -2 times 106 plus 17 and do the math. I'm not going to do that math right now because I just realized I'm being videoed and need to explain more of the basics, like what you were needing. Ms. Manichek, yes, Keandre? Okay, let me go back to the
It's
basics.
a lot of letters.
Hold on. Let's go back to the basics. Let me go back. Will you pause that?
Mm-hmm.